how much efficiency it is giving? It is giving an efficiency, this particular thing, these are taken from all from the experiments, and the validation with the experiment and simulation is also done at initial condition. So we didn't optimize this is the initial condition or of verification. Okay, then we check the details of this band gap variation, zinc oxide, biosynthesis we have done from the Redis route. Means, as you know, Redis has the zinc or copper, also other minerals. So we have obtained zinc from there, and one paper I have found that where he obtained this particular 680 nanometer peak absorbance they have obtained in zinc oxide. So same thing we have implemented, and we have optimized using the SCAPS 1D. All the datas, all the things we have shown, the interface defect density, which I told you we need to vary the things, and we have obtained the value. If you go for the defects, various defects, so if you can see that lesser defect is giving this value, why cannot you go beyond lesser than this? There is always a constant that we cannot go beyond this, because experimentally we have obtained this. All right, from it's based on, it need to be based on the experiment. You cannot do whatever you want. So here we have done, and there's an interesting figure here, that these type of curve, that is contour plotting, this 24.06 in this point, but it is moving how much at this point, right? We'll consider this maximum point. The maximum point will be 26.32. These are the optimized value, which is done for the first time using the experiment and using the SCAPS together, this combining both. So this type of work we have done. So up to this I am done. Yes, please, anyone's having question? Yes, Jyoti. Okay, no, yes, just a minute,
Yes,
Jayanta.
ma'am.
Yes, just a minute, there is some question. No, there I have seen in message. Okay, no problem. One by one I can do. Yeah, Jyoti, please tell. Mhm.
Hello, sir. Sir, you tell that triple graded active layer. Is in this you have used same type of perovskite cell, perovskite material. Is there any possibilities to do this triple graded active layer with some other perovskites material?
Definitely. Just a minute. Just a minute. Okay, I'll show you something. Okay. All right. I'll share one thing. All right. So the problem of the main problem was this triple grading, right? This is the first layer. This is the same material.
Mm.
Okay. And the second condition, this is the material. Okay. Combining these three and making it one.
Mm.
This is conventional way. This is the our way. Means if you separately, if you do it, all right, then
Mm.
there is
Mm.
always a possibility of lesser recombination. If you keep increasing this, if you go and simulate in SCAPS, and if you find
Mm.
almost 5 micrometer, if you directly simulate it, you will not get that much efficiency. And if you go do
Yes.
with different layering, and if you simulate that, you will find more value. Now your question, now I'll come to your question, that you told that whether it's possible. Definitely it's possible. You can try with the different layer, not only with methyl ammonium lead iodide. With the same material you can try, and you can obtain the more efficient device, and it will be new also. Okay,
Okay,
because
sir.
same device has not been done. Same device, double grading, triple grading. Okay, that is not been done. And in solar energy, I think I have published with Deboraj also. I have done that, so you can check.
Okay, sir. Sir, in escape, sometime we got that conversion fail error. So how can we overcome from this? problem.
Yes. Convergent failure means it the equation, right? There is some always a related equation with it. You cannot give, suppose whatever value you want, you just check out the experiment and just see whether it's possible to fabricate, sorry, to simulate that particular value in the SCAPS 1D or not. Now if you just simulate with, I have seen that if you just simulate the value using the random values of this electron mobility, hole mobility, then there is always a chance of convergent failure. So you just check that the primary concern I have seen, that more than that effect, you just go for the to the, just a minute, wait, I'll show you just now.
Okay, sir.
Okay, this is the interface, right? So let's think, these are the layer you have to add, keep adding. All right, so and other thing, this you know these things. All right, so now let's go, I'll load, I have already done one. Suppose this is the, this is the value now. Suppose CIGS methyl ammonium tin iodide, this value. All right.
Okay, sir.
Okay. So I'll just do one thing for making it clear to you. I'll do one thing. I'll delete this and whatever. You can put here. Okay. Just a random value I'm putting. It is not possible. Okay. I'm just putting a random value.
Mhm.
Now,
Okay, sir.
ah, and this V2 value always, you know, these there's that it must be more than the band gap, and
Hmm.
it's open circuit. You have to stop it. All right. So you just run it. Now it is coming. Okay, it's giving 18% or something like that. But all the cases, there are in certain cases the main problem comes in this. Better the, just don't go beyond this because it doesn't have that much effect. Okay, the main effect comes in this acceptor density, here hole density. Suppose whatever value you just put, right, like that. So these two are the prime concern. Suppose this one, that one, you need to concern of 5 6 parameter: band gap, electron affinity,
Hmm.
uh, these two, and six. These six parameter, if you can address, there is a lesser probability of this convergent failure. So you
Okay,
just
sir.
need to do that.
Okay, sir.
Okay, wait a minute. I have just changed some values, right?
Hmm.
It is giving 18% previously. Now it is
Hmm.
giving 20%. So now
20%.
you need to think that is it possible is it possible that CIGS is both acceptor as well as donor? Is it possible? It's not possible, right? So these are
Hmm.
the cases you need to concern. You need to take concern that it is whether it's possible to fabricate or not. Okay,
Okay.
you just consider one, two, this band gap, not that much, but electron affinity, permittivity, and these six parameters. You just take concern and keep changing the value. It is purely due to the electron hole, this mobility, and which is not accessible to the equation which is inside this software. So you need to work on that. Okay,
Okay,
so
sir.
exactly you cannot say. No one can say that why it is coming.
Okay,
You
sir.
have some which is not practical inputs you are providing. That's why it's coming. Yeah, please.
Sir, in SCAPS, some absorption file is there. So how can we select the absorption file? Is there any parameters? So because we have lots of file in SCAPS in
Uh,
absorption. So
yes,
how
yes.
can we select the proper absorption file for the
There
appropriate
is, yes,
simulation?
I have understood. You have chosen one thing, that please don't go for the choosing the file. Okay, you just go line this spectrum, right? Okay, these are the, you are talking about this, right?
Yes, sir.
Okay. Okay, this means 400 nanometer spectrum file. Don't choose these things. Okay,
Okay.
just go for 1.5 and you just simulate. These are particular thing I will show you. This particular thing, this particular spectrum file is used in tandem solar cell. This is given for the tandem. Okay, so you don't need to worry on that. You just put 1.5 and try to simulate that. I
Okay, sir.
cannot I cannot write here. Wait a minute. So for the tandem one, this is the top one. This is the bottom one.
Yes, sir.
What happens? This is the incident photon.
Hmm.
So incident photon is here, incident here, and it there is a okay. You cannot practically in simulation you can say no the how much photon is transmitted. Okay, then what you do,
Hmm.
you just propose this particular transmittance photon as it is called the spectral line. Okay, you just propose that how much is going through this. So for that particular thing, the option of spectral file is given to check on the bottom cell. But for the practical perovskite or CIGS based simulation, you don't need to do anything. Just select file, just choose 1.5. Already it will be chosen. Yeah, you're right. 1.5.
Okay, sir.
You don't need to worry on that.
Okay, sir. Sir, is there any possibility that we can create tandem without
Yes,
STL or ETL?